find the solution to this system, and we've been given two equations. So we've been given two equations and two variables, which means that we need to solve for both of them. One way you could solve this is you could say, oh, well, y is the same in both cases. So y is this and y is also that. So you could say that 2x is equal to x plus 5. In other words, you can set them equal to each other because they're both equal to y, and then you can solve for x. So if we do that, I want to move all my x's to one side. So x is equal to 5, which is wonderful, except it said solve the system, so I also have to find out what y is. In order to figure out what y is, you got to plug into either one of these. So you can plug into the first guy if you want. 2 times 5. Oh, it happens to be 10. If you choose the other one, it still works. So when you're giving your final answer, you can either write it like this, x is 5, y is 10, or you can write it as a set of coordinates, 5, 10. These would be your final answers. If you were asked to verify means that your answers work for both equations. So we can verify the first equation by saying, is 10 equal to 2 times 5? Oh, yeah, it totally is. Is 10 equal to 5 plus 5? Yes, it totally works. And so the solution that you have chosen, if it satisfies both equations, you know is the correct solution. So if you do this problem by graphing and you type these equations into Desmos, and you're wondering how to use Desmos, you need to look at the video that says how to use Desmos, desmos.com. It's a graphing calculator. It's not very difficult to use. You can just go there, type in the equations, and you will see that in part C, you're going to get two lines that intersect at a point. And that point was, I believe, 11.4, 2.6. And the decimals are approximate, and you can't convert them to fractions in Desmos, but that's just the approximation. If you look at this one, you're going to get two parallel lines, which means that they never intersect, so we're going to say that there is no solution. And in this case, if you graph this line, and then you graph this line, it ends up being right on top of each other. So these two lines are the same. They are equivalent lines. And how many places do they intersect at? All the places. They intersect at an infinite number of points. So you would say that there are an infinite number of solutions here. If they ask you to determine the number of solutions without graphing, then really what they're asking you to do is figure out whether they're the same line or if they're parallel. And to do that, they have to be in y equals mx plus b format. So this one already is, which is nice. This one, I'm going to have to rearrange a bit. So I can move y over to the other side. So 6x minus 1 is equal to y, or y equals 6x minus 1. So if you look at this equation and this equation, they're not the same, but they do have the same slope. So if you were to imaginary graph this thing, you would say that there's one going to be intersecting at 1, and there's going to be one with a y-intercept of -1, but they're parallel. They're both quite steep. Their slopes are 6. So they have the same slope, but they're not the same line because they live in different places. So they're parallel lines, and they're never going to intersect. So you say that there are 0 solutions or no solutions to the first one. If we do the second one, it looks like the first equation is not in y equals mx plus b format, so I can change that. I believe I can go 8x minus 13 will be the first equation. And then the second equation, again, is not in y equals mx plus b format. So I'm going to move 8y over to the other side. So x minus 13 is equal to 8y. Then I'll divide everything by 8. So y is x over 8 and -13 over 8. So if we're analyzing this, we're interested, first of all, in the slopes. Are the slopes the same? They are not. This slope is 8. This slope is 1 over 8. And the moment the slopes are not the same, you already know that they're going to intersect at some point. You don't know where, but they are going to intersect somewhere. Like, for example, this one has like a pretty shallow slope, and this one has a pretty steep slope. So at some point, they're going to intersect. So there's going to be one solution here, one point of intersection. Lastly, this one here, this one's already in a format that we like, y equals mx plus b. We can read that quite easily. So we're just going to convert that one to a format that we like. So 5y is equal to -x plus 10. And we'll divide everything by 5. And let's take a look at what we're left with. -x x over 5 plus 2. Wait a second. Negative x over the 5 is the same thing as saying negative 1/5 x. So if you look at this equation and this one that we just rearranged, you can clearly see that they are the exact same thing. And if they are the exact same thing, then you're going to have two lines lying on top of each other. And two lines on top of each other means that we have an infinite number of solutions. So we are looking for a k value that would give 0 solutions. In order to answer this question, you have to understand what 0 solutions implies. 0 solutions means that they never intersect. Never intersecting means that they must be parallel. And parallel means that they must have the same slope. But if you are extra brilliant, you will realize that these are not in a format where we can read the same slope. So you cannot simply say, oh, well, I need the value of this k to be 2 so it matches. It doesn't work that way. You need to convert them into a format where you can clearly see the slope. So I'm going to call this equation 1. I'm going to call this equation 2. So if we convert equation 1 into y equals mx plus b, I can move 2x and 4 over to the other side, and they become negative 2x minus 4. Then I can divide by k, and I will have this. Y is equal to negative 2 over k, x minus 4 over k. Then I can do the same thing to equation 2. So again, I will move all these pieces over to the other side. So 2y is equal to negative 4x plus 1. I will divide everything by 2. And I will have y is equal to negative 2x plus 1/2. So what do we do now? Now you have to be brilliant enough to realize that if they're parallel, their slopes are supposed to be the same. Well, they don't quite look the same, but you could choose a value of k to make it the same. In this case, you're very lucky because you could literally just look at it and say, okay, well, they would be the same if k was 1, which would be wonderful, and you would be right. But if it was more complicated numbers, then you would have to set them equal to each other and multiply both sides by k, and then divide by negative 2. And again, you're going to get k is 1. Okay. And so if you plug in 1 for k, you will realize that these two lines are parallel. So in this case, we're looking for a value of k that would give infinite solutions. So you have to read between the lines here and understand that means infinite solutions means that they are actually the same line, which means they have to be identical in every way, including the slope, including the y-intercept. But if we look at these, they are not in the correct format, so we can't read the slope or the intercept. So let's take equation 1 and we rearrange it. So y is equal to negative 2x minus 4 by moving those to the other side. And here's equation 2. So again, we can move the 4x over to the other side, and then we can divide everything by 2. So k over 2 minus 2x if you divide everything by 2. This is not quite in the right format because usually we write the x term first. So if I wanted to write this in y equals mx plus b format, it would be negative 2x plus k over 2. So this is the correct format. Here's our slope. Here's our y-intercept. So if we compare equation 1 and 2 in the format that we like, we realize that the slope is the same. That's good, because that means that we're one step closer to becoming identical. But in this case, it's not enough for the slope to be the same. If they are the same line, then the y-intercepts must also be the same. They don't look the same, but we might be able to choose a value of k to make them equal. So we would set negative 4 is equal to k over 2. And then we could multiply both sides by 2 to realize that k is negative 8. And that's how you would do it the standard way. You would convert them to intercept form so that you can see what's going on. And then you would set the pieces equal to each other that are relevant. Another way, if the equation is simple enough for you to see that these are possibly equivalent, let's take a look at equation 2. You could move the k over to the left side to try and make it look the same as the other guy. Now we have x's first and then y's, and then we have our constant here and then 0 on the other side. And you could realize that you can multiply this entire red equation, or we can multiply the blue equation by 2 in order to get the red equation. You multiply every term and the other side. And if you do it to every term and the other side, you haven't actually changed it. So the red equation is actually the same as the blue equation, just everything's multiplied by 2. And that's one way that you can spot that the equations are equivalent. But I will talk about that example in a later lesson. For now, if you can convert it to y equals mx plus b and figure it out, then that's good enough.